Hello everybody, this is our video number 6 on the same topic, the relation and the function. And in this video, we will solve the sum problem from the exercise 1.2, basis of the knowledge of the type of function. That means the one-one function, many-to-one functions, on-to functions and bijective function. So exercise 1.2 and start with question number 2.1. 2.1. The question is, check the injectivity and the surjectivity of the following function. The function f is a function from n to n. That means the natural numbers to the natural numbers, given by the definition of x is fx equal to x square. So first, how to prove these functions satisfy the one-one condition or not in mathematical. So first, let x1 comma x2 belongs to n. That means this n is denote the domain. So if you put the value of x1 in place of x, this produce x1 square and x2 is x2 square. Okay, and consider the f of x1 is equal to f of x2. That means it implies that the x1 square is equal to x2 square, and from this the x1 is x2. That means these functions satisfy the one-one criteria. Because what is the definitions of the one-one functions? Each and every element of the domain have some distinct image in its codomain. So that means at first we consider the two arbitrary value x1 and x2 which belongs to the domain of this function. After putting the value in this fx, it is produced the x1 square for the value of x1 in place of x and the x2 square for when x equal to x2. After that, we consider the value of this 2 is equal. If value of this 2 is equal, that means this x1 is x2 is also equal. That means the x1 is x1 and x2 is identical. Okay? And if we consider the f of x1 is not equal to f of x2, it is, and after that it is implies that the x1 is also not equal to x2. That means it is also the procedure to prove that any particular function is in fulfill the one-one criteria. That means if x1 is equal to x2, that means the image of both these two are equal. That means the image of this x1 and x2 is also equal. So we apply the reverse process. At first we find out the image of these two are equal. That means the pre-image image is also the equal. If it is not equal, if you consider that this is equal but it's not implies that these two are not equal, this time we conclude that this function is not satisfy the 1 1 criteria. Okay, so that means the f is one function or injective. Okay, and the next surjective. So as for this function, suppose this is our n, that means the domain, the natural numbers, and it is also the set of natural numbers, and it is represent a codomain of this function with respect of this function. So if you consider 1, you put the value in place of 1, it is produced 1. That means this 1 is connected with this one. After that, if you put the value of the 2, it connects with the value of the 4. In this manner, if you consider the 3, x equal to 3, it is connect with the 9. Okay? This connect with the 9. But if you consider the value 2 in the codomain of this function, this value is not connected with any value of its domain. So if you consider a value, this 2 is also belongs to this natural number sets, that means the codomain sets, but these two have no pre-image in the domain. That means all the element of this codomain is not connected with the domain set. So these criteria are valid, the condition of the surjective function. At that time, this f is 1 1, but not on 2 or surjective. Okay.